Complex numbers are written in the form a plus bi, where a is the real part and b is the imaginary part. You know what the square root of negative 1 is. What is it? And what is I squared? So I know you know how to do the basic operations, but just to make you think a little bit more critically, what if I asked you what the square root of I was? Meaning, what do you take and multiply by itself to get I? Negative 1 times negative 1 is positive 1. It's got to be something multiplied by itself. The fourth root of negative 1. What is the fourth root of negative 1? So, DeWalt, you've characterized this correctly, but trying to actually figure it out is rather difficult. In fact, by the end of this course, second semester, I will be able to tell you what the square root of I is. You'll find it kind of interesting. Furthermore, I'll be able to tell you the cubed root of 1 minus I roots of 3. Or what do you multiply by itself 3 times to get 1 minus I roots of 3? Looks ridiculous. You think you're not capable. Other classes in previous years have shown that they are. And I believe you will be able to do it as well. So let's begin our work. Today we are going to perform operations on complex numbers. We start by subtracting. You subtract the real parts, you subtract the imaginary parts. 4 minus 6 is negative 2. And 3i minus negative 8i is, in fact, positive 11i. So again, it's written in the form of a plus bi. The next one, I add and subtract. 1 minus I plus 3 minus I minus 6 plus 5i. So the real parts, 1 and 3, make 4, and negative 6 make negative 2. Negative I minus I is negative 2i, so positive 3i. Simple so far? Sometimes people look at the imaginary terms when we multiply them and they don't really write much down, and I get that, but you might make a mistake. So I like to write it as 28i squared. And then you know what I squared is? Negative 1. So therefore the answer is negative 28. The next one, I have negative 24i squared. So positive 24. The next one, negative times negative is positive, positive 2i squared. So the answer is negative 2. What's different about the next one? There's 3 of them. And so some people might write it then as 12i cubed. And I get it. But instead of writing 12i cubed, write 12i squared times I. What's 12i squared? So you get negative 12i. So I got 2 negatives. It's okay. So how would we write negative I cubed differently so that has I squared? Right. And since I squared is negative 1, we multiply them, we get positive I. Please take the next should take you about 9 minutes and try I to the 122nd. I'm kidding. Let's not take 9 minutes. Let's take more like 15 seconds. How would you rewrite it as I squared? Close. I squared times I to the 61st is I to the 63rd. You mean I squared raised to the 61st power, right? Everybody see that? Everybody agree that I squared to the 61st is the same as I to the 122nd? What is I squared? And what is negative 1 to an odd power? It's negative 1. Wow. Very simple. Flip it over. 3i times 2 is 6i. 3i times negative 5i is negative 15i squared. Again, you always want to write a plus bi, so the real part first. The real part is, in fact, 15. The imaginary part is 6i. The next two, what's going to happen when I multiply them? You got to FOIL it, and you're going to notice that the middles will cancel because what is the relationship between these two numbers? They are, starts with a C, rhymes with conjugate. They are conjugates. So we multiply conjugates, the middles cancel. We get 4 plus 2i minus 2i minus I squared. As we thought, the middles go away. You get 4. Instead of minus I squared, it will be plus 1. And I get 5. Please try the next one on your own. Go. Good. What's different about the next examples? You're dividing. We can't leave I in the denominator. We multiply top and bottom by I. I get 4i over I squared. And so I have 4i over negative 1, which is just negative 4i. Often people will want to multiply the next one top and bottom by 2i. I would discourage you from doing that. Just simply multiply top and bottom by I. What do I get in the numerator? And what do I get in the denominator? 2i squared, which is? So notice that the negatives cancel, and I'm left with 3 over 2i. Some people at this point get frustrated, like, Mr. Gens, move the I outside. 3i over 2 is the same thing as 3 over 2i. Those are equivalent. Would everybody agree? This is the preferred way of writing it because, again, we like to write as a plus bi. So in this case, a would be 0, the b value would be 3 halves, and then you have I. You may say it doesn't matter. It really doesn't matter a whole lot. I won't mark it wrong on the test, but traditionally, that is how you write it. Okay, that is how you write it. Any thought for this one? Close. Multiply top and bottom by I minus 1. Good. Shelby, why did I make that choice? Yep. Conjugate, the middles will cancel out. So I have 3i minus 3 over I squared minus 1. So the top I have 3i minus 3. And what do you get in the bottom? Negative 2. Now, I want to write it in the form of a plus bi. As you can see here, that's not in the form of a plus bi. Would everybody agree I could take 2 plus 3 over 5, and that's the same as 2/5 plus 3/5? So therefore, what I'm going to do here is I'm going to write it as two different fractions. Negative 3 over negative 2 is 3 halves. And then 3i over negative 2 would be minus 3 over 2i. So that's in the form of a plus bi. You try the last one on your own. Multiply by the conjugate. See what happens. Looks like I get 10 minus 4i minus 5i plus 2i squared over 25 minus 4i squared. So on the top, the 2i squared becomes negative 2. Combine that with 10, and I get 8. Negative 4i, negative 5i make negative 9i. In the bottom, 25 minus 4i squared, negative 4i squared becomes positive 4, so I have over 29. Write it in terms of a plus bi. 8 29ths minus 9 29ths I. Did you get it, Caitlin? Congratulations. You can pat yourself on the back. Please grab the worksheet I just handed you, and please look at problem number 17. Oh, oh, thank you. I'm sorry. I didn't pause for any question. Why didn't I FOIL the bottom? I did. I knew that because they're conjugates, the middles will cancel. So because the middles cancel, I don't even need to really think about it. Better? Okay. Square root of negative 3 times square root of negative 12. We'll do this one together. Okay? When I first did this problem, I wrote it as the square root of 36, which is equal to 6. However, that's not what the book had. They had a different answer. I'm going to show you why. I was never shown a problem like this before. I never really investigated it. But it looks like before you use the property of radicals, maybe the property of radicals only applies to real numbers. In this situation, you need to get rid of the imaginary portion, or I should say factor the imaginary portion out. Everybody agree that you could have this as I roots of 3? And the next one is I roots of 12. So when you multiply that together, you get I squared roots of 36. I squared is negative 1, and the square root of 36 is 6. So notice in one situation I come up with positive 6. That's incorrect. The other way I come up with negative 6. So make sure that you simplify it with the imaginary portion out front first. That'll produce a different result. The rest of the time is yours.